In this question, we're going to picture Big J, Mr. Jack, twirling his keys as he wanders down the hall. His keys are on the end of a 30 centimeter string. What we can imagine is the keys are kind of whirling around in a circle. So let's picture for part A here. Let's picture at the top of the circle. His keys are kind of whirling around like this. They're right here at the highest point, and that would put kind of the center of the circle, somewhere down here. And let's picture, my center's a little off center. There we go. Let's picture there's the string. Here's his keys right here. We're going to picture the forces that act on this thing. So now that I've made this nice dark line, let's get rid of that. And let's put in the forces here. What we've got are one force going down this way. That's going to be the force of gravity. But we have a second force pulling down this way at the same time. That's tension. So there's two forces pulling down. You might ask, if two forces are pulling down, why are the keys not falling down? And you have to kind of picture yourself whirling keys. If you whirl them in a circle, a vertical circle, at the highest point, they're not going to fall down as long as the keys are going fast. And it's because there's a fake force, a fictitious force pulling out this way. So we're not going to go into that too much here, but you can imagine this fake force is pulling out. I don't really want it to be on there. So again, I'm going to get rid of it, but it's inertia. That fake force is caused by inertia. So it's really just the object's inertia that kind of keeps it pulling outwards and prevents the keys from falling down at that moment. If you stop twirling them, then they're going to fall. At this moment, though, he's twirling them. He's twirling them pretty fast, 7.5 meters per second. So they're twirling around. They're not going to fall. They are going to accelerate towards the center of the circle, though, and we've discussed this a little bit, where I'm always going to choose towards the center of the circle as my positive direction. Okay, so when I start writing this Fc equals mv squared over r, again, my reasoning for doing this is not just because the forces maybe point in that direction, but because this acceleration, this v squared over r, is really an acceleration. It points towards the center of the circle. I like that to be positive. It just makes my work a little bit easier. If that's true, then I've got two forces pulling in that direction or pushing in that direction. There's force of gravity going that way. There's tension going that way. Both are going to be positive because they're in that positive direction as stated there. As we go through this then, we're looking for the tension. So we're looking for T. Tension is mv squared over r, and I'm going to bring this Fg over here, so minus Fg. Remember, Fg is just mg. And right there, we're kind of done, sort of, I would say, the tricky physics again. From here on out, it's just simple kind of subbing in numbers. So let me finish that quickly. I do want to come back and talk about this line. If we sub in our numbers, let's see, we got some mass. We've got V. We've got a radius. Mass again, 0.2 kilograms. G 9.8. And I'm almost out of room down here, so I'm just going to squeeze an answer in here. You can work out all this math. You're going to get 35.54. I'm going to round that and say it's approximately 36 newtons. Maybe I'll squeeze it right here. This is 35.54, rounded to 36 newtons. This tension force here is down, so we could say that it's down. Oftentimes when we do a tension force, we just kind of talk about the magnitude of the tension force, but it is down. I wanted to come back and talk about this line, but I'm going to go and do at the bottom of the circle first. So let's come over here for part B. Let's look at the bottom of the circle. And same thing is happening. So as it twirls around, now we're down at the bottom. So let's say something like that. So there's the keys right there. Center of the circle's here. I'm not going to draw my big line in this time, but you can imagine that the string is right here as these keys whirl around. That string then has this tension force, and force of gravity is still pulling down the same direction it was before. So this force of gravity hasn't changed, it's still there. Tension force, though, has changed. We know, just like we talked about here, the reason we chose this as our positive direction, now I'm going to choose up as my positive direction, so I'm going to switch it. The same question, but new part. I'm going to switch it again for the same reasoning, though. We know Fc is mv squared over r. This v squared over r is acceleration. I like towards the center of the circle as positive because I know this acceleration is in that direction. That way I don't have to worry about any signs in there. When I start subbing forces in, we're going to see tensions in the positive direction, but Fg is in the negative direction, so we're going to get a negative this time. And if I bring that Fg to this side, and let me just do one more line here, mv squared over r plus mg. Okay, so this is not a final answer. Let's kind of do a circular one, and over here I wanted just to compare. You can see these two lines are really similar, whether it's at the top of the circle or the bottom of the circle. You can see those two lines are very similar, but they are different by that sign right there. So just something to notice when you're at the bottom, those two things, these two quantities are going to be added together, which means this tension force is going to be bigger than this tension force because here there's a subtraction. What that means is as you whirl something around in a circle, the tension is greater when it's at the bottom and less when it's up here at the top. Okay, so that's just something to notice. That's going to come up in some future questions probably. Again, we're going to sub in numbers, and all the numbers end up being the same. So all the numbers that we had over here, still the same over here. Again, don't forget to square this. I've mentioned that before. Again, all the numbers are the same. The only difference is now it's plus. We can go through and add those together. This is 39, 46. We'll round it for significant digits. Tension's approximately 39 newtons. And again, I'll say up. Stick a little vector sign here. There's the answer to our question. Again, like we said, you can see this tension here is greater than this tension over here. Again, it has to do with those signs. Tension will always be greater at the bottom. We may run into this in a future problem where it asks, I think there's a textbook one where it asks about something about the breaking strength of the string, or where does the string break. If you whirl something around in a circle like this, it tends to break at the lowest point. That's where the tension is greatest. At the top over here, you can see the tension is less.